Dear students, this is Dr. Martha Srinivas. Welcome back to Master Academy of Mathematics. So once again, I just remind you regarding to the unit number 3 sequence and series of Mathematics 1, R18 and R20 batches, JNTUH Hyderabad. I have just given the important problems of unit number 3. Once again, you go through it, and today I am also going to give you the complete key of these important questions. Just you look onto this once again. So just it is only based on sequence and series. Maximum in the examination point of view, we are going to expect the problems related to the series. And this series basically divided into series of positive terms and alternating series. So if the method is mentioned, better you are going to use the method. Otherwise, you can use any of the methods. And every method is having its own specifications that you keep in your mind along with the procedure. You are going to use appropriate test. So first problem, just you look onto this. Second, third, name is mentioned for certain problems. In that case, you need to use definitely that particular method only. Interval of convergence is nothing but indirectly you are going to calculate the value of x for which the given series is convergent. Range of convergence, interval of convergence, limits of convergence, everything is same. And you are going to identify the value of x only. So these are the different problems. Even on alternating series also I have given. If no method is there, then depending on your given general term, you can use it. In order to use comparison test, remember that on simplification of general term, there should be one term looking in the form of 1 divided by n power p. Indirectly, you are using compulsory p test. Otherwise, comparison test is not applicable. And for D'Alembert's ratio test, just only un by un plus 1. Normally, it is applicable when the product of terms here it is given. And root test, Cauchy root test is applicable when the general term consisting of a power is n. And Cauchy integral test is applicable when the general term is integrable. If you can find out the integration of a general term, you can use the integral test. Rabi's test is applicable when the other methods fail. In that case, you can use the Rabi's test. And logarithmic generally, they won't ask you, but you need to remember there you are using always a logarithm of 1 plus x formula, and based on that you are going to find out whether the series is convergent or divergent. In the case of alternating series, first you need to verify whether the given series is convergent or not by applying Leibniz test, and on applying absolute convergence, absolute series, you can use any of the methods in order to verify it. If again absolute series also convergent, you call it as absolute convergent. If it is divergent, you call it as conditional divergent. So these are the 20 problems I have given corresponding to unit number 3. Now let us focus on the key or solutions of unit number 3 sequence and series. As it is, once again I am just giving you the first problem, and it consisting of 2 bits. So tan of 1 by n, in order to verify the convergence, you are taking the general term. Even though Vn is not there, but you are taking it as 1 by n, and on applying the p test, you can say that it is p is equal to 1 less than or equal to 1, it is a divergent. So you are applying limit for un by vn and applying the comparison test. Tan of 1 by n divided by 1 by n, it always becomes 1. So from that, limit is not equal to 0, but since limit not equal to 0 and summation vn is divergent, the given series is divergent automatically by using comparison. And for the second one, summation un is given, summation 1 divided by root n into tan of 1 by n. So on making the simplification, just you are taking vn is nothing but 1 by root n into n, which is nothing but n power 3 by 2, which is on applying p test, it is greater than 1 convergent. You are applying a limit for un by vn, and again it is limit not equal to 0. You can say that given series is convergent. And here is second problem, 2 power q by 1 power p, and like that it is given. And when you write the summation n plus 1 whole power q divided by n power p, you are selecting the general term and you are taking n common along with the power. On cancellation, you are getting one answer. Then you are selecting a vn. Whenever you select the vn, it should look like 1 divided by n power p. So denominator 1 divided by n power p minus q. Applying p test. In order to say it is convergent, that power should be greater than 1. So just you are applying limit un by vn, and finally you are getting the answer 1 not equal to 0. So you can say that it is convergent under the condition p minus q greater than 1. Third problem, here it is given. So instead of doing in this model, my sincere suggestion is better you apply rationalization process. Rationalization means you are just multiplying with root n minus of root n plus 1. అంటే అక్కడ ప్లస్ ఉండే దగ్గర మైనస్ అని రాసేసి యూ మల్టిప్లై విత్ అండ్ డివైడ్ ఇట్. ఆన్ అప్లయింగ్ ద రేషనలైజేషన్ ప్రాసెస్ యూ ఆర్ గోయింగ్ టు గెట్ అన్ ఆన్సర్. ఫ్రమ్ దట్ ఆన్ మేకింగ్ ద సింప్లిఫికేషన్ యూ విల్ గెట్ vn term, and so that you can decide your answer. Fourth problem here is given, and there you are writing the general term, and here clearly mentioned that you are using D'Alembert's ratio test, finding un plus 1 and un by un plus 1. Just you are making the simplification, and after getting that you are just substituting the limit, and you are getting an answer which is it's not equal to 0. Actually we need to say that it is limit should be greater than 1. If it is greater than 1, then only you call it as convergent. So by D'Alembert's ratio test, it is greater than 1. Don't say it is not equal to 0. Fifth one, you are getting an interval of convergence for this D'Alembert's ratio test. So on applying that summation, you are selecting the general term, calculating un plus 1, then un divided by un plus 1. So on getting one particular information, and directly on making the simplification, you got this. On applying your limit, you are getting the final answer is 1 by x. So as per D'Alembert's ratio test, limit should be greater than 1 to get the convergent. So you can say that 1 by x greater than 1, or it is 1 greater than x, or you can say that x is less than 1. X less than 1 means it can take up to 1 only. You can also start with minus infinity to 1. So you are calculating range of the convergence of the given series. Again by using D'Alembert's ratio test, you are finding un plus 1, doing the simplification, and finally you are getting the final answer is 1 by x. So in order to say convergent greater than 1, that is your range. For the seventh problem, you are using the root test in order to identify the value of x. Root x, here the power n is there, so automatically you are going to use Cauchy root test. On making the simplification of nth root of general term, finally you are getting an answer, and on applying limit you are getting only x value, and to say it is convergent, limit should be less than 1. So that is your conclusion. Use integral test for this problem. Clearly the name is mentioned. So n divided by n square plus 1 is the general term. You are calculating the integral. So it is looking like f dash of x by f of x type, logarithm of f of x. So logarithm of x square plus 1, and directly you are applying the limits, and directly you are getting logarithm which is undefined value. Wherever the limit is undefined, if it is finite only, you call it as convergent in the integral test. Even it is undefined or it is infinity, in both the cases you can say that it is divergent. You are using Rabi's test for this problem. So Rabi's test is nothing but you are calculating un and un plus 1, finding un by un plus 1, and for the remaining values un by un plus 1 minus 1 you are taking, and on making the simplification, directly on doing the cancellations, and you are getting its value 4 by 3, which is greater than 1. So automatically you can say that it is convergent. Show that the problem is given absolutely convergent. It is an alternating series. Directly first you check your given series is convergent or not. So by Leibniz test you can say that it is convergent. On applying modulus you are getting that. Just you are using any of the methods in order to test 1 divided by 2n minus 1. So just you are taking, of course, D'Alembert's ratio test here it is used. So on making the simplification you are getting an answer, and in D'Alembert's ratio test if the limit is greater than 1 you call it as convergent. 11th problem, alternating series is given, whether it is convergent or not. So look at this 10th problem. Previously that alternating series is convergent, and finding the absolute series we got it is convergent. So previously convergent and this is also convergent, we call it as absolute convergent. For the 11th problem of alternating series, so on applying Leibniz test you are getting the total equal to 0. That means you are not getting any x term. So for all the values of given series is convergent. అంతే, మనం ఏం చేయాల్సింది లేదు, ఎందుకంటే ఎక్స్ అనే టర్మ్ మిగలలేదు అక్కడ. 12th ప్రాబ్లంలో ఫైండ్ ద వాల్యూ ఆఫ్ ఎక్స్ ఫర్ విచ్ ద సిరీస్ ఈజ్ కన్వర్జెంట్. ఇట్ ఈస్ ఎ సిరీస్ ఆఫ్ పాజిటివ్ టర్మ్స్. సో ఆఫ్టర్ గెటింగ్ ద జనరల్ టర్మ్, దట్ సమ్మేషన్ ఫార్ములా, and you can use any of the methods. So here it is given un by un plus 1, D'Alembert's ratio test you are applying, and we got finally it's 1 by x, final answer. So in order to say that series is convergent, that limit should be greater than 1, so that you are getting the x value. 13th one, test the convergence of that particular information. Maximum in the case of examination, either you can use a comparison test, D'Alembert's ratio test. These are the two important methods in order to get. If you are getting power n, then only you can use root test. So here it is given, and final root test limit is less than 1, then you call it as convergent. Suppose a problem is given, if you are using different methods, you may not get same type of conclusion. In one method it may be convergent and another method may be divergent. Rare cases. Majority you may get same, but sometimes. So test the convergence of this. So here it is given, and better in that case you are applying D'Alembert's ratio test, and on making the simplification you are getting a value, so which is infinity, that is greater than 1, it is convergent. For the 15th problem, you are finding the radius of convergence. Indirectly you are calculating the value of x. So better you take any of the methods. So here it is given D'Alembert's ratio test, and finally we got it for limit answer 1 by x cube, so that it should be greater than 1 to be convergent. And another problem, you need to test whether it is absolutely or convergent or not. So for this alternating series, by applying Leibniz test it is convergent, and on applying modulus you are getting absolute series. Just making the simplification you are getting Vn, so it is divergent because p equal to 1, which is less than or equal to 1, and on taking limit un by Vn you are getting a value 1 which is not equal to 0. So since summation Vn is divergent, you say that by comparison test the total series is divergent. సో ఇక్కడ ఏమవుతుంది అని అంటే, ఇచ్చింది ఆల్టర్నేటింగ్ సిరీస్ కన్వర్జెంట్ అయింది, ఇక్కడికి వచ్చేసరికి డైవర్జెంట్ అయింది, కాబట్టి వీ కాల్ ఇట్ as ఆపోజిట్లో ఉంది, ఇట్ ఈస్ కండిషనల్ కన్వర్జెంట్ అంటారు. 17th, టెస్ట్ ద కన్వర్జెన్స్ ఫర్ దిస్ ప్రాబ్లం. సో మ్యాక్సిమం హియర్ యూ ఆర్ యూజింగ్, అండ్ విఎన్ టర్మ్ ఇస్ దేర్. ఎప్పుడైనా యూఎన్ని సింప్లిఫై చేస్తే విఎన్ టర్మ్ ఎగ్జిస్ట్ కనుక అయ్యేది ఉంటే యూ కెన్ యూజ్ యువర్ కంపారిజన్ టెస్ట్. So finally limit not equal to 0, based on that summation Vn you are giving the final conclusion. range of convergence, here it is given. Product of series is there. Better you are using డిఎల్ఎంఎట్స్ రేషియో టెస్ట్ ఫర్ దిస్. ప్రోడక్ట్ ఆఫ్ టర్మ్స్ ఎప్పుడు ఇచ్చినా కానీ అదే యూజ్ చేయండి, ఈజీ అవుతుంది. ఒకవేళ అక్కడ మెథడ్ ఫెయిల్ కనుక ఏది ఉంటే అప్పుడు ర్యాబీస్ టెస్ట్కి వెళ్తారు. సో హియర్ ఇట్ ఈస్ గివెన్. 19th లిమిట్స్ ఆఫ్ కన్వర్జెన్స్ ఇన్ ఎక్స్ప్రెషన్ ఇస్ గివెన్. సో ఆఫ్టర్ రైటింగ్ ద జనరల్ టర్మ్ యు ఆర్ క్యాలిక్యులేటింగ్ అగైన్. మ్యాక్సిమం మీరు యూజ్ చేసుకుంటే సరిపోతుంది. అన్ని మెథడ్స్లలో ఫస్ట్ 2 మెథడ్స్ మ్యాక్సిమం యూజ్ చేస్తారు. సో 20th ప్రాబ్లంలో యు ఆర్ ఫైండింగ్ ద ఇంటర్వల్ ఆఫ్ కన్వర్జెన్స్ ఫర్ ద గివెన్ ఆల్టర్నేటింగ్ సిరీస్. ఆల్టర్నేటింగ్ సిరీస్ అది చెక్ చేయండి. ఫైనల్లీ ఆ ఎక్స్ అట్లాగే మిగిలింది. ఇప్పుడు లిమిట్ సబ్స్టిట్యూట్ చేసినప్పుడు ఎక్స్ పవర్ ఇన్ఫినిటీ అని అంటారు. మరి ఎక్స్ పవర్ ఇన్ఫినిటీ ఏమవుతుంది అని అంటే, ఒకవేళ ఎక్స్ గ్రేటర్ దెన్ 0 కనుక అయితే ఎక్స్ పవర్ ఇన్ఫినిటీ ఈజ్ ఇన్ఫినిటీ అవుతుంది. అంటే ఇన్ఫినిటీ బై ఇన్ఫినిటీ అని అంటే క్యాన్సిల్ చేసి 1 అనకండి, అది అన్డిఫైన్డ్ వస్తుంది. కాబట్టి నేను ఏం చేశానంటే ఎక్స్ వాల్యూ ఒకవేళ 0 to 1 మధ్యలో ఉంటే ఎక్స్ పవర్ ఇన్ఫినిటీ ఈజ్ ఆల్వేస్ ఈక్వల్ టు 0. సో ఆల్వేస్ ఈక్వల్ టు 0 అంటే ఆ టోటల్గా లిమిటే 0 వచ్చింది. అందుకని మనం ఏమంటామంటే దట్ యూ కాల్ ఇట్ యాజ్ ఇట్ ఈస్ కన్వర్జెంట్ బై అప్లయింగ్ లైబ్నిజ్ టెస్ట్. సో దిస్ ఈజ్ అబౌట్ ద కీ పాయింట్. కొన్ని ప్రాబ్లమ్స్ కూడా దీంట్లో చెక్ చేసి చూడండి. నేను ఆల్రెడీ ఓవరాల్గా రెక్టిఫై చేసుకుంటూ చెప్పాను. ప్రాక్టీస్ చేయండి. ఎనఫ్ యూ విల్ గెట్ మ్యాక్సిమం స్కోర్ ఇన్ యువర్ ఎండ్ సెమిస్టర్ ఎగ్జామినేషన్స్. ఓకే, థ్యాంక్ యూ.